Good afternoon, everybody. Welcome to another one of our virtual tour of outer space. My name is Josh, and I normally would tell you I'm broadcasting from my home to yours, but today you may have noticed I'm in a little bit of a different context. You can kind of see around me. This is not my house. There's not my snake isosceles back there. I'm actually in the bowels of the planetarium, way below where our guests normally interact. And that's because the California Academy of Sciences is now open again, which is super exciting for us. So if you, like many folks we've met today, are excited to return, we would love to see you. But until our dome reopens, you're going to keep doing these virtual broadcasts since we can't send you planetarium shows. So for today, I get to take you on a virtual tour of outer space. If there is some spot in our solar system that you would love to check out, by all means, put it in the comments. My producer, Mary, can let me know. We can actually go there and see it for ourselves. So we're using today a software called OpenSpace. You can see the sun floating right there next to me. Now, the sun in OpenSpace is actually just it's floating in a white void. It's actually the glare of the sun. Back out a little bit, you can see space around the sun. Give it a kind of context. This is something really cool about our software is that it enables us to render a map of the universe, and it's one that you can experience too. A lot of planetarium software tends to be expensive to the point where really only institutions are buying it. OpenSpace is something very special. It's free planetarium software, open source, as a matter of fact. And if you want to download it, play with it yourself, this is a really cool thing to do. So while we are flying around, if you want to do the exact same tour for your friends and family at home, you be the planetarium presenter. You can do it. Just download the program and fly them around. Now, for those folks of you who are checking in, thank you for letting us know where you're coming from. If you have ideas about where we should be heading, by all means, drop those in the comments. In the meantime, I'm going to start us off. Okay, backing away from planet Earth, let's go visit a frequently requested object that's not too far away from the sun. I said the sun. We are going to go visit Mercury. Okay. I'm hearing from some folks our sound is an issue. I deeply apologize. We're going off the internet that was available here. I will work very hard to make sure that I'm delivering a smooth and consistent delivery as much as possible, and we can work with the sound. Okay. Let's see. We had a request for Io as well. I think we can go visit Io, but right now we are seeing the most interesting part of Mercury, the lit up side. Now, you might notice this Mercury looks very dark. Why is this the lit up side? Well, it's the side the sunlight is hitting. Mercury does rotate, and it does revolve. Those are two different actions. I'm sure you can piece out what each of them means about it long enough. But what we're talking about in space is how something spins as it orbits. Because of Mercury's unusual spin and orbit, for a long time, we thought that it was locked, so that only one side ever faced the sun. The other side always faced away. Now, if we look at right here, this partially lit up portion of Mercury, this would be the side that was in perpetual twilight. According to that old story, this side was always dark, always cold. This side was always super hot, but it could be hospitable around here right in between them. The idea was that, well, maybe human beings could land on that part of Mercury and hang out there. It's not the case. For a number of reasons, that's not the case. Turns out that Mercury does rotate and revolve, so it's not always facing the same direction. It has a 3-to-2 orbital resonance, so every part of Mercury does something. Now, it also means that, well, it turns out the equatorial regions around there would not be a good place to live. But the polar regions of Mercury are still pretty exciting. Now, the polar regions of Mercury, the planet that is closest to the sun, would be just about the last spot in the solar system where we would expect to find water. And it turns out we have found some water at these polar regions. Now, it's ice. Turns out a lot of the solar system water we're finding right now is ice. But is Mercury tidally locked to the sun? Not quite. It has an orbital resonance, but it does still spin a little bit. Now, it takes about, a little more than its rotation around the sun for it to spin once. So on Mercury, a weird thing to think about, a year is a shorter amount of time than a day. Finding ice in those polar regions was a really big deal, but actually it brings us to another very exciting discovery that came out this last week, which is the discovery of water on Earth's moon, much closer to home. Turns out, a lot like Mercury, the moon is not a spot we've thought of water accumulating. Now, that was a discovery that got thrown out the window when we discovered that there was water on the moon, actually ice. Richard's talking about a crack that's widening on the moon. That's a different discovery entirely. I haven't spent as much time researching that, but it is definitely something we see, a changing surface. Okay, so looking down at the moon, we don't have too much to show off where they discovered water, but I will tell you, if you go back to our cosmic conversations and find the one with Brian Day, you can hear him talk about the likely presence of water on the moon. We actually checked some of those sites out. And if you want to see where we found water, go to the SOFIA telescope's press release. They can show you the specific spots around those polar regions. Now, I've got to say the SOFIA instrument is one of the coolest things around. It's a plane with a telescope built in the side. I got to fly on it once upon a time with my coworker Nick, and it is a wonderful experience. About the coolest plane around. I mean that. It was very, very cold on our flight. Only part of that was because the telescope has to be at around 3 Kelvin. Okay, why are there so many holes in the moon? Looks like someone took a drill to it. This is why my wife keeps saying it looks like cheese. What we're seeing here are craters, spots where something is bashed into the surface. There are some actual holes on the moon's surface, what we call skylights. We think they're lava tubes that are partially exposed to the surface of the moon. And that gives us a little window to the inside of the moon. But most of these dots, divots, and dents are just that. They're places where an object fell, smashed into the moon, and left behind one of those craters. Now, we can see a lot of craters on the moon. We can tell their history based on which ones are on top. We can even tell a lot about the size of a crater based solely on its shape. By studying the shape of an object, you can learn about how it was formed and the angle at which it formed. So let's see if we can spot an irregular crater. Right over here. No, that's a multi-component crater. We can see what's probably a lava tube, though, right there. If I zoom in a bit more, this could be one of the spots where we see those actual legitimate holes. If you look right here, that wiggly line looks relatively straight, has small bends in it. You can sometimes see, if you were to trace these for long enough, dark spots. Those dark spots are where this lava tube has a partially collapsed region, and that little hole could be a place where we want to send human beings one day to live on the moon and offer a lot of protection from the solar environment, particles being sent off by our sun. We had a question about the American flag. That is a great one. So, is the American flag still on the moon? Yes. I can do you one better, though. There are 6 American flags on the moon. One of them has been knocked over. We know that when Apollo 11 blasted off, they knocked over the flag they had positioned at the Apollo 11 landing site. You can see that right over here. Now, we can't actually see the flag. I know a lot of people want me to be able to zoom in so much that we can see the flag perfectly on the surface. You can do that with some parts of OpenSpace, but you're only going to see a shadow of where the flag was set up. And that's when you bring in specific high-resolution imagery. Trying to spot the flag in a photo like this is kind of like trying to spot a tennis ball on a map of Texas. The object is really small. The area is really big. It's impossible to try and just pick it out. But if you do want to find those high-resolution images, I know on Apollo 15 and I think Apollo 17's landing sites, you can actually make out where the flag is. Some of those have been bleached probably significantly by the sun, so it's going to look like they planted white flags on the moon's surface, like Earth was surrendering to the moon. But some of them probably still have little bits of color on them. So we'll be able to tell they were American flags if they're careful enough when they examine it. We did have a request for Io first, so I want to head out that direction. Looks like we can make a stop at Titan after that. You folks are picking out some awesome moons for us to visit, so thank you for doing that. Oh, Summer has a follow-up. If the moon's made of rock, which we know it is, they put a flag on it. Is the surface soft enough for them to plant a flag in? Well, it turns out a lot of the moon's surface is what we call regolith. Regolith is just dust. It means rock covering. So that dusty regolith was soft enough for us to put a flag in. They may have had to hammer some of them in a little bit. I want to double check. But parts of the moon are dusty enough for us to stick a flag in. Okay, looking down on Io, though, this is not a place human beings have landed. No human has traveled beyond the orbit of our moon. Now, zooming in a bit more, you can actually see some of these regions have a lot of color change. What's going on here? Why does this moon look like a pizza? Well, what we're seeing is a volcanic surface, highly volcanic. These smooth areas are where material has been deposited from these volcanoes on Io. Looking around on Io, compare it visually to what we just saw on the moon, what we just saw on Mercury. When you look at those places, they have tons of craters. Turns out Io is about the same size, so it should have a similar amount of craters, right? It's probably about the same age too. Then it's got this big red spot we saw Caroline picked out. That looks like a volcanic plain from this central area. This might be a big volcano, maybe one that's spread out around it. That's the red spot you're thinking of. Now, I'm not positive, but based on the shapes I'm seeing around here, I would guess one big volcano here and a big volcanic plain surrounding it. So when we look at Io, this is a smooth world. When we look at the moon and we look at Mercury, we see bumpy cratered surfaces. Those are actually older surfaces. If they're the same age of object, how could one have an older surface than the other? Well, we know Io is geologically active. There's new stuff coming up, old stuff going away. So the surface is constantly being renewed, refreshed. When we look at the moon, when we look at Mercury, we see a surface that has been solid rock for a very long time and has picked up a lot of craters over that time. So let's think about that when we head out to visit Titan. If the surface is smooth, it's going to have a very recent geological history. If the surface is bumpy, it's going to have a much older geological history. Okay, heading out to Titan. As a long trip, normally spacecraft take between 5 and 7 years to get out to the area around Saturn. We can do it in less time. Looking at Titan, you're going to notice a different color. This is a black and white image. Titan's probably not this color up close. But this black and white image shows us radar imagery. So we bounced radar waves off the surface of Titan. Areas that are smooth show up white. Areas that are black are going to be absorbing more of that. Now you can see these blackish areas over here. We actually think these might be an ocean. There's also some dark dunes on the surface, material spread out across the surface. So Titan, this moon, let's compare it to the two we saw before, the three we saw before. Would you say this is a smooth, new surface? Or would you say this is a bumpy, cratery, old surface? Think about it for a sec. I can keep flying us around. Just to make sure folks are aware, this is Titan. This is the largest megamoon of Saturn. Now, I can pick out a few definitely discernible craters. I see one right there. If I look over here, I can see another pretty obvious crater. But in general, I would say this is a new, relatively fresh surface. Now, that's because with very much crater-free areas, we can say that, well, it's either been very well protected, maybe by its atmosphere, maybe by its planet, but more likely, there's some processes going on. Turns out those oceans could be a major part of it. When water, or liquid I should say, flows across a surface, it can wear stuff away. Water erodes structures here on Earth. Now, we can see not water flowing on the surface of Titan, but stuff like rocket fuel, methanes and ethanes make a liquid on the surface. As it flows, it would wipe away material beneath it. We think there is erosion processes going on Titan, making it a relatively new surface. Because it rains on Titan, liquid moves on the surface, we're likely to say that this is a newer, fresher surface. Okay, so I got another object for you. This is not a planet. It's also not a moon. That should be something of a head scratcher. We're going to have to head very far from the sun to be able to see it, but it is still part of our solar system. What am I talking about? Pluto. And when we see Pluto, use that same metric we used before. You say a smooth surface, bumpy surface, or somewhere in between. Therefore, is this an old surface, heavily cratered, a young surface, very smooth, or somewhere in between? Looking at Pluto in this view, I can see craters. I can see a lot of icy, broken up regions, places where I have no problem saying this is an older surface. Especially around here, I can see a lot of craters, I can see a lot of mountains, cracks, and valleys, relatively old. We think Pluto formed alongside the rest of our planets in terms of the age of our solar system. It's probably about 4.6 billion years old. It's pretty old. Let's see some weird features. Check this part out. When you look at this part of Pluto, you can see where sunlight is shining. I can see a very bumpy mountainous region, but fewer craters, at least big craters. And then when I look at this part, how many craters do you see? Hold on 1 second. I'm going to turn off nighttime on Pluto so we can see the entire surface. We can see, well, basically no craters. It's a little bit of a better view. Looking around here, I can see a lot of bumps and lumps. I can see some mountains poking out of this sludge, but there are no craters here. We think this is something like a nitrogen glacier or lake. It's not solid. It's kind of mushy, liquid. Let's call it semi-solid. Now, this is made of the same stuff as our air here on planet Earth. We would think of our planet's atmosphere as being mostly nitrogen. This is nitrogen soup floating on the surface. Whenever something smashes into it, it probably just goops up back over it, and we're left with a new, fresh surface. So Pluto is one of the most interesting, active, geologically amazing objects in our solar system without any correlation to whether or not we call it a planet. So I think a lot of people got very sad when we first announced that Pluto is not a planet. It doesn't mean Pluto is not part of our solar system. It doesn't mean we don't care about Pluto. It means Pluto has more in common with some of the small objects. Ben recommended Makemake. I don't think I have Makemake loaded up, but you can go see pictures of Makemake. However, I don't know if we have a good model. Now, when we look at these other objects in our solar system, we have to remind ourselves these are things we are still just beginning to learn about. They're exciting, they are new. There's a lot of unknowns in this situation, but that's exciting. It's a wonderful part of astronomy today. We have the opportunity to build our knowledge of objects in our own solar system. And one of the coolest and most exciting things about that is we are just at this point in human history beginning to discover that there are other solar systems that have a lot of traits similar to our own. So let's check this out. I'm going to hit this button. Theoretically, it should do something. Hold on 1 second. There we go. Oh, they disappeared. See those blue markers? These represent all of the stars we've located that have at least one planet going around them. Most of these markers are not just single planet solar systems, though. They're probably multiple planet solar systems. And we can see some parts of our sky, like right here where the Kepler Space Telescope was observing, that have tons of stars with planets going around. When we start adding all of this information up, we begin to understand that our solar system is not special. Our solar system is commonplace. There are tons of other solar systems that are probably very similar to our own. But when we point a telescope off out at one of these other stars, we can just barely discern that there are planets there. We usually can't see the planets directly. Not always true, but we can't really get good information about an individual planet. So if we want to learn how many of these planets might have moons, or how many of those moons might be Earth-like, or how many of those moons might have water, well, we don't have any information about that yet, because we've never really discovered a moon around an extrasolar planet. So when we have amazing, huge discoveries like there's water on our moon, or there's volcanoes on Io, or Titan has an atmosphere very similar to Earth's, that's really big. We don't have the ability to learn about other solar systems yet. So if we want to make a guess, educated, informed, scientific guess, we have to study our own solar system, especially the moons of our solar system, to give us a better understanding, so that we can try and approach this question more accurately in the future. So with that, I'm going to start heading back to Earth, but I'm happy to make one more stop along the way if anyone has another object popping out, something they would like to see. But if not, I would really like to thank all of you for tuning in. If you come back next week, we will do our very best to make sure that we have all of our audio and video issues sorted out. Every time we change the setup, more bugs to fix. Looks like we have a request for Uranus. We can definitely make that happen. Thank you, Laura. One more object to visit. Let me get rid of these exoplanets. So you see those blue colors for the rings. We often think of blue as something special, different, exceptional. Here at the Academy's Color of Life exhibit, we learn how few animals actually have blue coloring. Turns out in our solar system, we have a robin's egg blue world. Sometimes Earth gets called a blue planet. That's nonsense. We're a gray, brown, white, green, yellow planet. We have a lot of blue to be sure, but it's not the only color we have. Uranus is a blue planet. Maybe blue-yellow, but mostly blue. It's amazing to see. I love those light colors and dark colors. You can see those are clouds moving around on the surface, and those clouds are following jet streams. Jet streams move along bands of latitude. And if you start putting that together, this is a band of latitude. This would be sort of a band of latitude. This is Uranus's North Pole. This yellowy region right here. Now that's extra weird. If I were to show you the orbits of the planets as they go around the sun, something like this, you can see all of a sudden the plane of our solar system, how objects are moving around our star. Notice all those other blue lines off in the distance? Well, that means that Uranus's North Pole isn't up here like you might expect. It's on the side. So imagine for a moment if you lived right here at the North Pole of Uranus, not that it would be a great place to visit, I don't think you could even walk on the surface, but if you were hanging out there, you stationed an observer here, at the summer solstice, when the sun is highest in the sky for the hemisphere you're on, the northern or southern hemisphere, doesn't really matter, you would be able to see something really cool. The sun would not rise, the sun would not set. When you go and see from the Arctic Circle, you can see the sun make a big circle around you. That wouldn't be the case here on Uranus' sort of Arctic Circle. You would just see the sun stationary in the sky, spinning around in a little pirouette. That's bizarre. That's weird. That is totally different than our Earth-based experience, but nonetheless would be something very cool to check out. I don't know if human beings are ever going to make it to Uranus. If they do, probably they'll have bigger things to worry about than what the sun looks like on different days of the year, and the year is very, very long. But if you throw all those facts aside, this would be a pretty cool thing to check out. Okay, heading back. Summer asks, is that why it's called the sideways planet? Yes, absolutely. Of the major planets of our solar system, Uranus is the one with the greatest tilt. So it's leaning over on its side the most. However, of all the planets, I should say the including dwarf planets of our solar system, Pluto has a very severe tilt too. And actually, depending on how you define tilt, Venus might have the most severe. Venus has almost no axial tilt. Seasons don't mean much on Venus, especially below that thing magnetic atmosphere. But Earth's nice 23.5 degree tilt gives us our seasons. If we wanted to spin like Venus does, it sort of spins clockwise, not counterclockwise like the rest of the planets. It's counter to the rest of the planets is the important detail. That would mean its North Pole is where we have our South Pole. Its South Pole is where we have our North Pole. But if that's true, then it's been flipped by 180 degrees. We don't have a good explanation for why that would be the case. There are some people who suggest a collision. Basically, every time physicists don't understand how something happens, they suggest a collision. It doesn't really seem to fit. With that, I would say we are back to planet Earth. I would like to thank all of you for joining us here for our, let's call it another kind of interesting test case of how we can do a virtual tour of the outer space. But again, if you are able to tune in next week, we promise to have these bugs fixed up. If you want to tune in tomorrow for our night sky update, Big Quack will be telling us about all the cool things we can see in our night sky. And this Friday, we are speaking with Amy Mainzer about some asteroids, comets, and worrying small stuff that exists in our very own solar system. And with that, thank you all for joining us. Have a wonderful rest of your day. Stay home, stay healthy, and we hope to see you at the Academy sometime soon. Check out OpenSpace. Have a wonderful rest of your day.